Hello everyone, this is the second video to Python data types. Let's learn about what are data types, or you could say data formats, and then we'll be learning about type functions. Type functions are to manage and verify data types. Don't worry, you'll learn about each and everything. And then we have mutable and immutable data types. So for mutable and immutable, get right into it. There's basic understanding what is a mutable and what is an immutable. So first of all, let's just destroy a variable. You've created your variable in the previous class, and then in this class we'll destroy your variable, right? Let's have a variable, a superstring, right? A superstring with the value hello, and for some unknown reasons you want to change the value of hello to superstring by, right? So what we have exactly done is, let's just understand how this code block works. So as soon as you define a variable, we know that it's a box. It saves a value inside of a box, right? That's the basic understanding. So if we have one inside of the box, and then if we create the same box with the same label, with the exact same label, and then we put two inside of it, right? We put two inside of the same box. 2. So what exactly would happen in this case? What exactly would happen is, if you have the same box with the same label or the same name, what would happen is, first of all, your computer would save this box into its RAM, and then it would override this block with the new value. So what would really happen is, when you created the superstring and then rewrote the superstring, you would have the rewritten value. So it's a sequential language. It goes line by line. It first processes line 1, then it processes line 2, and then it processes line 3, and then so on. So if you would say in line 1, you would consider string as 1, and then in line 2 you would say string is 2, and then if on line 3 you say string is 3, then what exactly would happen is, your string won't be registered at 2, and nor would it be registered as 1. So of course it would be registered as 3, right? So if you would print the string here, it would print as 3. So guess, if I print the string here, what would exactly happen? What exactly would happen is, it would print 2, because the last value saved in the string or in the box is 2. Let's just consider it as the default understanding of the box. So first, in line 1, we created a box named string, and in the box we put the letter 1, and then in line 2 we told the box to, oh, your name is still same. In the same box we put 2. So what would happen is, we would remove the 1 and put the 2 inside of it, because we're using the same memory block and we're overriding the memory block. So this is concepts of mutations. Now there's some type of mutable types, and then there are immutable types that cannot be changed after they're created, right? They're immutable, right? Let's get into it. So for the first data type, we have integers. So integers are whole numbers without a decimal point. What does this mean? I'll show you. So why are there exactly two same to take numbers, integers and float? They both to take numbers, but the main difference is, one takes with the decimal, the other one takes without a decimal. So let's get into the example. So basically, I would put something like your age in a variable called with the data type integer, right? And then there's conventional. First of all, I forgot to tell you, but the most important thing is conventional naming of integers, right? If you're creating a variable which is intended to store age, you'd rather want to store it with the variable name age, rather than store the age of a user in the variable called name. You're getting with what I mean. This would end up creating utter confusions, and then the other developer would think, oh, this is created for your name, but somehow you've put the check of integer there, right? So if someone puts something like a name like Walid in it, it would say, oh no, there's an error in this. Why so? Because you put an integer type there. It only accepts integer, and Walid is definitely not a number. It's something of including alphabets, so it's not an integer, it's of course a string. So let's get into it. So you would call an age and then you would store your age 14 here, right? So this is the basic understanding, and then here, right here, you've created a variable. But now you want to ensure that it is always an integer. So you put the value int, which stands for integer. You put this on your data, right? Your data was 14, and then you put the data type integer onto your data. So just consider this like a wall or a boundary outside your box, or like a filter on your water dispenser, only allowing integers. It won't throw any other thing than integers. Similar to water filters, they throw anything, they don't give you anything other than pure water. Similarly, it gives you anything, anything that is integer and nothing else. This is how an integer works, right? So what is the core difference between an integer and float? If you haven't guessed by now, in and float, you might want to store something like decimal points, like 25.5. Now where would a float really be used? A float really would be used in something like currency. If you want to store amount, and then you want to say 25.5, you want to say I have $25 and 5 cents. You want to say I have 150 bucks and then I have 50 cents. So you want to store 150.50. You want to store it like this. Now here you would want to use something like float, and float would be more preferable to use here rather than integer. Okay, so now that we're done with numbers, we might as go with the next example. We have strings. Strings, as we did in the last video, are one of the easiest one. They are anything, basically. You can call it anything, and then they can be your they can also be an age, they can also be a number, they can also be special characters. A user might want to use this as a password. When you're asking for a password in your program, you might want to use something like a string. So now let's get into the next one, which is booleans. So what exactly is a boolean? Boolean is one of the tricky data types, and how exactly it works is that we ask the user for a data type in between true or false. They can't really input 3 4. They can't really input something like ABC. They can't really upload something like a special character, so that is not allowed. The only two things that they can do is true or false. Now where this might be used is something like is authenticated equals to true, which will show you if the user is authenticated or not authenticated. I'll give you an example. If a user, like I have a LMS at my school, so like if I go into my results tab and if I try to share my result, which is private, which is on my access wall, if I share the direct URL for that particular result, like example.com/result.pdf, if I share it with my friend, it won't really open. It would rather take me to example.com/login. Why so? Because there's an authentication layer here, and it's asking us to please authenticate. So once the user is authenticated, once he has signed in, then we can make this true. If he hasn't, then we can make it by default false. So making sure that the user always signs in to see his own result, to see his own dashboard, to see his own details rather than seeing anyone's details. Just think about it. You just go on Instagram and you're able to see everyone in the world's private account. That's not really how it works, right? So this is how it is made possible through Boolean, right? Let's get into the next example, which is lists. So lists are ordered mutable collections of items. So what by mutables, you will know that a list, just a basic understanding of a list is an array. What really is an array? An array is basically multiple variables, right? Multiple variables in the same variable, right? So what you would do is, let's just consider 1 2 3 4 and then 1 2 3 4, right? Let's just consider this as an array. So how this exactly works is that each box, of course, has its own label, right? And then a value stored inside. But rather than the label, now we have something called a sequence number, right? A sequence number. So I'll explain what a sequence number is right here. So let's just consider you put 1 2 3 4. inside of the array. You have 1, 2, 3, 4 elements. Each element in the array is called an element, right? And then you have 4 elements in your array, and then let's say you want to show the user only the third element, right? You don't want to show him the second, the first, or the fourth. So how exactly that would work is, you won't really call the third one. What you would do is, an array, the sequence number starts with 0. So you would go 0, 1, 2, 3, and you will want to call 2. So you would not call 3. You will not know what value is inside of this. So a user could, conventionally, he could put like anything inside of it. He could put, let's say, the best example, of course, he could just put anything inside of it. And then now why a sequence number is needed, because our program really doesn't know what that value is inside of the anything. So like before, we can't really print the label, rather we have to print, or we have to use the sequence number, and you can get any value which is put inside of this box using the sequence number, right? So let's get into the code and just make an array yourself. So this is your first array. How an array works is, you use square brackets, and then you use speech marks inside of the square brackets, right? You put hello like this. So it doesn't really, this is a basic one. Let's just combine both. So this is an array with one element, right? This is an array with one element, but unfortunately this is not the first element, right? This is the element 0. So if you would want to call it, you would call the element 0. So how you would do exactly, let's call this sample array, right? And then how you would exactly call an array would be that you do sample 0, and this would print the first, which is of course hello, to the user. Now let's say you have an array with multiple headers. You have hello, you would have another hello, and then you would have next hello. So you have so many hellos inside of the array. So how the array exactly would work is, if you want to call the third element, you would have to do 0, 1, 2. So we'd have to do array 2, and if you print it, you would get next hello, right? This is how the basic concept of an array works. And then of course it is mutable, you can change it later on. So now that we know how lists or arrays work, let's go into tuples. Tuples, first of all, are immutable, right? You cannot change it once they're defined, right? So let's get into an example for immutable tuples, right? So tuples, you would usually assign tuples as, something like this, 180 to 44, which is the best example of a coordinate. Now currently we might not use it, and I'd say rather a practical would be to just put it like in a pandas or like in a CSV and then read from the text file. That could also be done. So that really is not used as much, I'd say. But one of the practical use case for this is OpenCV apps. Now what is OpenCV? OpenCV is basically graphical processing, or it allows you to do image processing via machine learning, AI. So that is the best example to actually use this. You'd commonly see people using tuples when they're using OpenCV. So now let's get into the next example, which is dictionaries. Dictionaries, unordered collection of key value pairs. I don't think I really need to write this one down because it explains itself. So in a dictionary, you could have multiple characteristics saved directly into one kind of a variable, right? So you say person and you have one characteristic, the name, right? You have the name, and then you have the age directly saved inside of one person, and then you could call that particular value to check a person's name, a person's age directly through only one variable. Then we would have sets, which is an unordered collection of unique items, right? The unique numbers 1, 2, 3, 4, 5. These are unordered. They can be 5, 4, 3, they can be 5, 4, 2, 1. They're unordered, right? Now we have the function type. For this, we'll jump into the code editor. So what exactly is type? So let's say you have a string, you have a superstring, right? You have a superstring called superstring. Let's just make sure that it remains always as a string. We don't want it to change it later on. So I have a superstring here, And then what I really want is to check if it is a string or not, right? So how we can really check it is by using the type function. We could put superstring into it, and this would return with if it is, if it is a string, if it is an int, this would tell us exactly. Now let's say I want to throw an error if it is not a string. Let's say we only want to allow a certain data type. So what we can do right here is use is instance function. What is instance would do is you could put the function, you could put the variable name superstring right here, and then you could put a check here. You would want to check if it is integer, you would want to check if it is string, you would want to check if it is float, you would want to check whatever you want to check. You can just put here and it would return with true or false based on this. This is a boolean, so it would return you with true or it would return you with false. One of the best examples of boolean is actually in robotics. So how a sensor really works is, I'll show you live how a sensor works, right? How a sensor would work is, as it would be getting lights on it. Let's say it's this one is like a sunlight detector. What it would do is whenever it's getting lights, it would convert that into an electrical signal which would push ones rather than zeros, and then you would read 1 or 0 based on true or false. This is the basic understanding of how a sensor works. I hope later on we could also do some fun robotic stuff on this channel. So today we've learned data types, we've learned how to actually manage and verify our data type, we've learned what is the difference between a mutable and an immutable data type, and we've learned a lot about 10 different functions, 10 different data types today. It was a great day, and I hope we'll be learning something new tomorrow.